We start a new project and create a new file and define the corresponding project directory. The system configurator can be found under the tab B Software bNX. This video shows the Linear 250 product line. The manufacturing process of a component is planned in standardized work areas, the process windows. This structure is loaded via the assembly structure plant development file. Additionally, prefix and suffix can be added. The folder structure has been integrated into the existing file. The different modules are available under Process. The tool is created under Linear. The Lean tool is automatically inserted at the correct structure position. The magenta-colored process windows that define the work areas can now be seen. The Lean tool can only be positioned at the defined coordinate systems in the Linear process window. The next step is to fill the first Lean tool. Therefore, the folder have to be switched manually. Before the tool can be created, the strip must be placed. To do this, the AS stage plan component provided for this purpose must be opened. The process windows are also listed here. With the forming study, forming stages were defined, with which the strip was developed. This strip is now added and the constraints are opened. Positioning is done via coordinate systems. The required coordinate systems are displayed with layer 80. The strip lies on the process window cutting and linear. After the strip has been installed, you can start with the individual components, like punches. For the individual parts, the folder has to be changed manually. The first punch can be placed. One coordinate system appears for each stage. Punches are thereby assigned to the stages of the strip for positioning. With the value input you can customize the punch. The new values are entered in the field and the stamp changes with Enter. To the right, under Comments, you can find the limit values. The punch is positioned over the bottom three fields. In parallel, you can work with the bNX measuring function or use values to approximate the desired geometry. For the stamp contour, the stamp is adjusted with standard functions. Here the contour is sketched and extruded. The direction can also be changed, depending on whether the punch should come from above or from below. The pendulum angle refers to the coupling. For the piston it is the swivel angle with limits ±10 degrees. After the punch, associated couplers and suspensions can be added. A selection of possible coordinate systems appears through the added punches. Preview images help at the beginning when dealing with the software. The command, create whole shape volume model, is available under the value input. This pulls the deposited whole shape volume models, shown in green, from the blanks. Desired allowances for clearance can be added to the blanks. Now you can add more components for the tool. The machines can be found in the process general. The machine independence allows the machine to be added before, during or after the design of the tool. The folder will be automatically selected again. Additional versions can be selected. The configured machine is loaded and added to the assembly. The machine can be added and changed at any time. A machine-independent structure with always the same 0 point. After the machine has been selected, further components are available in the different processes. Here you can see the finished tool. The first placed punch. Many more punches, inserts and central mandrels were created. The blanks, in red color, are individually adapted depending on requirements. In the timing chart, the movements are defined according to the VDI 2143 laws. The aggregates of the selected machine are selected. The NC driving profiles are exported for the VC1 control. The timing chart is also added to the simulation. In the simulation, the individual bodies are assigned to the movements in order to obtain a movement simulation of the tool. In this way, movement sequences with springs, rotations and dependencies can be perfectly checked and illustrated. The normal NX functions like hide and measuring can be used. A inching mode can be used to stop and measure precisely. Optimizations are easily detected and can be changed in the tool and functional plan. The simulation is updated automatically by the continuous process. Tool and machine are combined with all their functions in the new system configurator.